Corbin and Forrester, and this is a journey through the human genome.
This is a journey through the human genome. Craig Venter, we've done something quite extraordinary today. In all of our 13 years of work, it only took us until April 2003 to decode the entirety of the human genome.
We've come a long way since 1990. Sure, we fished the first draft in 2001, but this is something bigger than that. Something even grander than that, Francis Collins.
And we're ahead of schedule, 2.5 years more or less. The Human Genome Project was the exploration of human DNA. We encountered newer, more efficient technologies, along with medical breakthroughs.
We can't forget about the exchange of information and technologies on a global level.
Not to mention the work done by and exchange of information between Rosalind Franklin, Francis Crick, and James Watson. If they hadn't discovered the double helix structure of DNA, the Human Genome Project would have never been possible.
It's hard to believe that there was ever a time when people thought that decoding the entire human genome would have never been possible. Adenine, thymine, guanine, and cytosine, God's code, if you will. These are the acids that make up DNA and are represented by A's, T's, G's, and C's.
It is the scientific rule that A's and T's will only connect and G's and C's will only connect.
When Rosalind Franklin came around in 1952 with that big brain of hers, she composed Photo 51, the first piece of evidence ever to prove the double helix structure of DNA.
If it weren't for that, and Francis Crick and James Watson's encounter of that information, none of what we have here today would even be imaginable.
Developed and ready. I think Photo 51 will finally be able to prove my research. 1952 will be the year where my work in DNA is successful and recognized all around the world. Why, DNA isn't just strands of genetic code, but according to this image I took using X-ray crystallography, it is a double helix ladder of interlocking ATs and GCs. I think it is the foundation that describes the traits of every human being and organism. From here, who knows? Maybe one day our entire genome will be sequenced.
Don't mind if I take a look at that, thank you.
That's my photo!
Don't worry, it'll be an awful lot more useful than our hand-stock lady, who needs X-ray crystallography and photographs when we can build three-dimensional models instead. Mr. Watson and I believe it's a much more efficient way to study DNA.
Ugh, imbeciles. What could you possibly know about X-ray crystallography?
Actually, quite a lot. X-ray crystallography uses X-ray radiation to determine the shape of the molecule that has been crystallized. As the X-ray hits and goes through the molecule, their beams diffract in specific places.
With looking at the pattern of the diffracted molecule, scientists are able to look at the arrangement of atoms in the molecule. We understand how this is an okay method to studying DNA, but why look at patterns in a molecule when right under your nose there's a model?
Clearly, you can see why you've decided to take the path of model building, while you lag behind in important and new scientific technologies. Welcome to the 20th century, Rosalind. Models are in, X-rays are out.
Francis Crick, let's be professional. After all, it's not her fault that our studies and encounters are fundamentally better than hers. We ought to start on a model of this right away.
It's a fine proposition indeed, sir. No longer will we be the clowns of the scientific community.
That's my work. I won't let an ignorant American and stuck-up Brit take credit for my success just because they haven't any idea what they're doing.
It's not just us taking credit for your work, but your very own colleague, Maurice Wilkins, is also involved in all this.
How could he? He worked in X-ray crystallography with me.
Don't worry, you'll be dead by 1958 anyway. This whole thing will pass over her head before she knows it. James Watson, Maurice Wilkins, and I will go on to win a Nobel Prize in 1962 for our outstanding work in discovering the double helix structure of DNA. While Rosalind would have died from all of the radiation exposure due to her work in X-ray crystallography. I told her it was a bad idea.
Everyone wins here. Wow, I cannot exaggerate how important the exchange of information in the scientific community is. If it weren't for our encounter with Rosalind Franklin and the exchange of information with her, Francis Crick and I wouldn't have been able to further explore DNA and its double helix structure.
It was James Watson, Francis Crick, and Rosalind Franklin who advanced the field of biology. They set the foundation for DNA research after the discovery of its double helix structure, and they made studying the human genome possible. That is why the Department of Energy and its representatives, including myself, decided in 1990 to start the Human Genome Project. Our goal was to identify all of the approximate 30,000 genes in human DNA. Because of the exchange of information with other scientists and countries, we have been able to develop a sequencing method to further explore the chromosomes with genes in our DNA, otherwise known as the human genome. Without the Department of Energy, the Human Genome Project would have never been funded, or even started for that matter.
If I do recall, it was being thought up in 1988. Our collaborators, the National Institutes of Health and the U.S. Department of Energy, were the ones who started thinking up the idea for the Human Genome Project.
That's right. Several meetings were held with the Department of Energy and the National Institute of Health in 1988, where a plan was thought up to study the human genome. Then, in 1990, the two groups released a published plan for the first 5 years, out of an estimated 15, for the Human Genome Project.
Obviously, new plans were made, and we've made 3 in total revisions due to accelerated progress.
A lot has happened since then. The exploration of the human genome has led to many important scientific encounters, along with the exchange of information on a global level.
Over 1,000 researchers hailing from 16 different institutions, like the National Institutes of Health and the U.S. Department of Energy.
You know, the Human Genome Project was one of the few scientific collaborations to be funded by the government. Not just the U.S. government, but 6 different governments around the world. Astounding, isn't it? There are at least 18 different countries building their own genome projects now, but ours in 2003 is over.
Essentially what we've done here is create an instruction book for our own existence. We can look at diseases and ailments from a new light. We can better diagnose diseases and even predict the individuals that are bound to carry them beforehand. No longer will medicine be a game of chance, but rather a custom drug meant to aid the individual.
This is all because of our ability to sequence genes the way we do. Back in the 1970s, Fred Sanger developed the modern method for decoding genes.
The Human Genome Project used a different approach than my private company, Celera. We both used the Sanger method, but our approach to the methods were different.
While Celera Genomics attempted to sequence a genome as a whole, the Human Genome Project sequenced smaller strands and then pieced it together like a puzzle.
Not just that, but technology's advanced too. No longer working with X-ray crystallography and models like Rosalind, Watson, and Crick used to.
The world of computers has skyrocketed, so it only made sense that the project latched on along with it. Faster and more efficient technologies means for faster sequencing than ever before. Technology allows for the mass storage of all our information.
None of this would have been possible with physical copies of the sequences. With digital storage, we can store genomes aplenty and provide that information for the rest of the world to use in clinical use and research studies.
As you can see, the exploration of the Human Genome Project led to the exchange of information all around the world.
The Human Genome Project has changed the way the scientific community views collaboration with other scientists and the exchange of information between them.
It's led to faster and more efficient technologies, which led to the sequencing of the entire human genome.
We can now use information from DNA to treat, cure, and even prevent sicknesses that affect humans every day.
Not just in America, but all around the world.
We can now specialize medicines for the sick.
We can improve our diagnosis of diseases.
We can develop better treatment methods for the ill.
The Human Genome Project will help save lives.
The Human Genome Project will expand the field of medical research.
The Human Genome Project will change the world.
Okay, thank you very much. Go ahead and clean up your project, and then as soon as you're done, we'll ask questions.
All right, perfect.